In this video, we'll graph the truncus function y equals -2 divided by x minus 5 squared minus 3. And now because the function is expressed the way it is, we can immediately identify any transformations to the graph. So the first transformation we can recognize is a reflection in the x-axis due to the negative out the front here. The second is that it's been dilated by a factor of 2 from the x-axis, which comes from the 2 on the top of the fraction. Next, we can identify that it's been translated 5 units in the positive x direction, and that's because of the x subtract 5 in the denominator. So if we take the 0 of that bracket, so if we have x minus 5 equals 0, we find that x is equal to 5, and that is the equation of our vertical asymptote. So I'm popping that in with a dotted line. So that is x equals 5. The last thing we can recognize is the translation of 3 units in the negative y direction from this -3 here. So that means that our horizontal asymptote has an equation y equals -3, which is somewhere along here. Next up, we need to find any x and y intercepts. So the y-intercept occurs when x is equal to 0. So if we put that in, we find that y is equal to -2 divided by 0 subtract 5 all squared minus 3. So this gives -2 over -5 squared, which is positive 25. Minus 3, which is the same as 75 divided by 25. So we have that y is equal to minus 77 on 25, which gives a y-intercept at 0, -77 on 25. And that's going to be this point just here. So that is 0, -77 on 25. Next up, we can find any x-intercepts if they exist. So the x-intercepts occur when y is equal to 0. So with this in mind, we have 0 is equal to -2 divided by x minus 5 all squared minus 3. So if we add 3 to both sides, we have 3 is equal to -2 over x minus 5 all squared. Multiplying by x minus 5 all squared, we have 3 x minus 5 all squared is equal to -2. And now if we divide by 3, we find that x minus 5 all squared is equal to -2 on 3. And now if we take the square root of both sides, we have x minus 5 is equal to plus or minus the square root of -2 on 3. And this isn't a real number, so this means that there's no solutions, which means there's no x-intercepts. So with that in mind, all we need to do is now graph our negative truncus due to the -2, which means our function will look something like this, with the graph approaching the asymptotes but never quite touching them. So the domain of this function, this is the set of all the x values allowed inside the function. So if we inspect all the x values, we can see that we can put any real number excluding +5 into the function, and in the range, by inspecting the graph, we can see that it starts -infinity not included and goes all the way up to -3 also not included. So on this slide, we've just got the function graphed neatly by a computer, and you will note that -3 0.08 is equal to negative 77 on 25. So both are exact answers and acceptable. And here we've got the same asymptotes, x equals 5 and y equals negative 3, as we did on the previous slide. And finally, over here, we've got the maximal domain and range, which we also found.